All right, thank you everybody for coming. We have Alex this week, who is a Penn State postdoc. You want to talk a little bit about what you've done first, and then we can dive into the weather briefing.
Yeah, I did my PhD here with Dr. Evans, looking at tropical cyclone clustering, and among others, tropical cyclone clustering to improve forecasting and to better understanding ensemble variability within an ensemble forecast, and specifically looking at cases of the extratropical transition of Hurricane Sandy. Right now, I'm doing a little bit of work where I'm looking at how Sandy's sort of developed into what we call a warm seclusion type structure, and how that differs from the canonical warm seclusion that occurs after extratropical transition. But today I'm just here to. I'm a postdoc with Penn State now, but I'm living in Frederick, Maryland. So came up here to meet with my advisor and to also do this. So the first thing we should talk about is the weather here, since that's most directly applicable and relevant to our lives. And what we've got going on right now is this 12Z GFS, it's certainly reliable that you've got what looks to be a shortwave trough moving through the area. Now, of course, this is no ordinary shortwave trough. This is the ghost of Hurricane Irma. So we track the vorticity back a day. You see the hurricane coming out, recurving in the Peninsula Ohio Valley, and now the remnant vorticity is over us. And that's what's giving us the clouds and the showers. And it's pretty good. You can see you're hit by what was once a Category 5 hurricane. So, but clearly we're seeing a little bit of rainy weather. And that will likely, the trough will likely be somewhat slow to move out the next, not super slow, but move out, moving out slowly the next day or so. And so there'll be scattered showers and some clouds through the next day. It'll be a little bit probably tomorrow will be, I'm not a forecaster about trading, so we'll touch it out. Yeah, the weather tomorrow a little bit warmer, a little bit less chance of showers. And then it could get an upper level ridge could build in after that, which will give us very good weather through. And so you see this is the 500 millibar heights, the trough associated with Irma dissipates and moves out, and further dissipates and move out. Replaced by good ridging over us, which will reduce the chance of rain to zero over the very early weekend, early next week. Give us quite warm, probably somewhere above average weather for this time of year. We're forecasting highs around 84 for Saturday and Sunday, and then similar into early next week. That's exactly what they are forecasting. 80. So really great weather, and so. There's a football game on Saturday, just knockout weather. I mean, certainly the best of the three days we've had. Certainly, world was better than the first game. It felt like we were all over. But yeah, it'll be mostly sunny, slight chance of showers before say 9 a.m. Or early in the day. Not even before 9 a.m. It's a slight chance of showers during the day, but really it'll be mostly sunny and a little bit above average temperature-wise. It should remain good weather throughout the day, so it'll cool down by kickoff with the sun setting and then throughout the day. But it should stay, I would imagine it should stay in at least the upper 60s during the daytime. Again, I would take what I'm saying with about the weather itself here, something with a grain of salt. This isn't anything I'm trading. I can model somewhat with the forecast, but basically, the upside is the weather will be very good for the football game. Unless you're exceedingly cold sensitive, there's no need to bring a jacket. And speaking of people who are exceedingly cold sensitive, I wanted to give a shout out to my mother, who I think is watching this from Washington State on video. It's her birthday. I wanted to say happy birthday to her. If you've ever seen the show, if you've ever heard of the third Dr. G medical examiner, you probably have it, but that's okay. That's for her. But back to the weather, this good weather with the mid-level ridging and warm temperatures, sunny weather should stay with us through the middle of next week, unless obviously the track of Jose, which I'll get to in a little bit, could disrupt that slightly, although Jose is likely not to catch us directly. So ultimately, in the next 5-6 days, you should, after Friday, which will be a little bit like today, but a little bit warmer, a little bit better weather, should be pretty tranquil weather. Around highs of roughly 80 next several days. Most of the sun is very good sort of late summer, early fall weather. Now the things that really are what I'm here for, I think, are the various and sundry tropical cyclones around the world. And what we've got really a pretty active globe right now. Obviously, this is in the northern hemisphere. It's mid-September, so you would expect the northern hemisphere to be active. The southern hemisphere to be inactive. You've got recently downgraded tropical storm Jose, which is northeast of the Bahamas. And it basically has been assaulted by wind shear, some of it due to the residual outflow from Hurricane Irma during the last couple of days. And it's gradually weakening to a major hurricane down to a tropical storm. Now, this is not to mention right now it's passing over its own weight from the counterclockwise move that it did, which is to say it's probably moving over cooler water temperatures than which we normally expect in that part of the world at this time of year. However, during the next couple of days, the environment is expected to become more favorable in the upper levels for Jose, and it will be moving over warmer waters, so it should strengthen. And I'll get a little bit into the track in a short time. In the East Pacific, we have two fairly new tropical cyclones. Hurricane may be shown in the same picture, which is usually rare to have two storms this close together. But we've got Hurricane Max, which is quite a small hurricane, but you can see the eye right here just off the coast of Mexico. And it really just formed, I believe, yesterday as a tropical depression and rapidly strengthened just before landfall. It's obviously the best of landfall now. And these are the type of cases that really scare the forecast. When you have a small storm in close to land, it's not going to be affected by landmass because it's small, and because it's smaller, it can blow up or blow down in a real hurry. And that's what happened with Max. And I think the forecast from yesterday, when it was a 40-mile-an-hour tropical storm, essentially said little change in intensity is expected before landfall. Which that's not to rag on the Hurricane Center or anything, and the models weren't really picking it up either. I think it's just that these small storms are very hard to simulate, especially using the global model to say still 10, 15 kilometers. The Max will make landfall today in southern Mexico as a hurricane, and given the terrain in this part of the world, there's really unfortunately, a pretty good chance for a lot of flooding and mudslides that would the upslope flow along the mountain in that part of Mexico. And Norma, which is a larger but weaker storm to its left here, is much less diffuse core, which is named today, will be around a bit longer. It's expected to track northward toward the Baja Peninsula. I think the DFS and some of the other models move it actually across Baja into the Gulf of California and then into mainland Mexico, whereas the European model keeps it a little bit west of Baja. So either solution is possible at this point. But certainly the people in the southern part of Baja California and even the west, the Gulf Coast of the Gulf of California, keep monitoring the storm. It's expected to intensify and be at hurricane intensity in that area. And then don't want to also forget there's a weak tropical depression 15 in the East Pacific, which has really been essentially a monsoon trough, perhaps almost that these two cyclones have developed from the Eastern Pacific. And this one is the weakest of the three and the least impressive, and it's simply moving westward and is unlikely to be strengthened substantially or it will not affect it. And then in the West Pacific, we've got Typhoon Helene, which really was an impressive looking typhoon yesterday. The satellite presentation has degraded substantially. Now, that might be due to some southwesterly shear or moving over colder water, although I know these intensive forecasts are not predicting the weakening this one. They seem to be maybe the satellite presentation is degraded, but really hasn't weakened substantially. But it is expected to remain a typhoon and then head northeastward making landfall in southern Japan and probably sometime later tomorrow on Asia Island. So those are the current cyclones we've got in the Atlantic Basin, or the world, excuse me. Now the question is with Jose, what's going to happen? And now, right now, Jose is south of a subtropical ridge, essentially, that rotated around the cyclone, causing it to do its counterclockwise route. It will be moving generally west-northwest for the next day or so. And then it looks like it will find, this is the most recent GFS forecast, I'll pull up some other forecasts as well. It will find a weakness in the ridge that develops and then get pulled northward. And then how a lot of the impacts will be that could happen on the East Coast or not will be determined by essentially how quickly the weakness in the ridge develops, so how far west it gets before it starts turning north, and then how much region there is once it gets farther north to its east. Because depending on the amount of region to its east, that can cause it to either go essentially due northward toward southern New England or even hook left somewhat, or just cause it to scoot more zonally out to sea. So this being now, I think that just from having this completed a loop, there's still, I think the models are still to some extent trying to get a handle on exactly how far west it's going to go and then how strong the region is going to be to northeast. But it really, most of the models, really all of them, at this time have it staying east of the U.S., although it does get uncomfortably close to New England, and this, of course, is the 6 days from now, which means that forecast error at this time frame is quite large. The European has a similar solution. This is the 0 from last night, where it is the U1 will be between 2 and 3 today. And so that takes us a little bit closer to the East Coast. So it's not far off the Cape Hatteras, so far enough to not have substantial effects in 5 days. And it moves quite close to New England between 6 and 7 days, so around 6 days from now, which again, the models have been doing different things. A couple of days ago, it was getting stopped, or yesterday, it was getting stopped south of New England for a couple of days, weakening into the cold water, and then getting actually pushed back westward into making a deep landfall in the Atlantic. So there's still a substantial amount of uncertainty. I think the fact that don't be misled necessarily by the fact that all the deterministic models are essentially showing the same course. I think that the very most likely outcome is that yes, it does go out to sea, maybe it brushes New England slightly, but I would not be shocked if the models are under the strength of the ridge and it gets a little bit farther westward before turning north and moves a little bit closer to the coastline. So there is, looking at the ensemble forecast, and I don't have the European ensemble tracks in front of me, but the GFS does have a substantial minority report. Maybe not substantial, but about a quarter of the solutions will take the storm north and then shoot it back westward due to likely stronger ridging develop, upper level, mid-level ridging to the east and northeast of the storm developing in those solutions. I think it's somewhat important to keep in mind that this is the GFS ensemble. It really tends to be, I found, under-dispersed, and it will often, essentially, the storm will often take a track outside of any of the ensemble members, because just from whatever the GFS does to, or whatever it can do to perturb the ensemble, but not perturbing it. It's getting all the tracks essentially within a narrow area. So basically, that is saying that the fact that you're still getting some tracks shooting it to the west after, just say 100, some number of hours, is indicating to me that there's probably still substantial uncertainty in the forecast, and that really people from North Carolina and northward here, I guess really Maine, still keep a weather eye out on this storm. Although I would say the chance of landfall is fairly remote, but cannot really do that. And so I think the UK net is but we can't take a look at that. But we can also take a look at some of the simulations for the other storms. Actually, let's, yeah, in the other storms in the East Pacific. So we see, yeah, you see the three cyclones here associated with this general sort of monsoon trough setup east and west of Mexico. Hurricane Max, tropical storm, tropical storm Norma, and tropical depression 15. Max will move in, and you can see how much trouble the global models are having representing small hurricanes. But Norma is predicted to intensify and move northward. This is the best view of the European bit. So it really strengthens into a substantial hurricane because it's low to 9.9, although again, I wouldn't trust these global models, especially the best right now. But it basically makes it into a substantial storm that moves into California. Whereas depression 15 becomes a storm that just moves westward. And if we look at the European, I believe it keeps it a little bit farther west. Yes, it actually has a little bit more rigging and keeps it west of the Baja Peninsula. But that's certainly something to watch if you, out of curiosity, if you have interest there to see which solution ends up verifying, whether it goes a little bit more east or whether it goes a little bit more west, it stays west of Baja California. No, it's general guidance. Yeah, the general guidance is actually online right now with the PFS, and perhaps not quite as far west as the PFS, as far east. I get east and west confused for East Pacific, so I'm west and out to see. Not what I used to thinking, but yeah, most of the global models and the hurricane models as well do take it into Baja California. So it'd be interesting to see what ends up verifying there. And with Aline, or Taylor, essentially, the models are pretty tightly clustered. They'll move into southern Japan, and then the heat, and of course, the movie is well, I'll be interested to see if we redevelop some of the structure. It's really eroding over the past few hours. And there's also the possibility, of course, of more Atlantic tropical development down the road. So don't speculate too much. Things within the models of additional main development need to be developed. Although we're getting into we're not late for main development yet, but we're getting a little bit late for main development that will impact the US. Because if you get in the mid-late September, you tend to get more stronger troughs moving across the Atlantic, greater weaknesses in the ridge. And so it's so easy to get a major hurricane main development can make things after it's scooped up more easily. Really affect the US, they have to form a little bit farther westward, like say, but it's still certainly possible. This is actually a handful of true Cape Verde storms that have formed and impacted. Formed September 15th or later and impacted the US. And so the EC does have a current wave that's off of southwest of the Cape Verde Islands, becoming a tropical cyclone, weakening like we do to vertical wind shear, but then coming back together a little bit more as it moves toward Bahamas. And then the PFS is what we would expect a somewhat more aggressive wave. It's the most recent run. Developing into developing it into hurricane and then moving it to the sea. after that. It's speculative, so. Who knows? But note also that the GFS still has Jose around. Now, I don't think that will happen, but it's not inherently impossible. It could move east and just get just under the ridge and just far enough south that it doesn't dissipate with the marginal water temperature. And then just hang out, make landfall in within Newfoundland, 11 days. 12 days. I don't think that will verify, but it's certainly a possible solution because they got stuck once and why not do it again. But no, in serious, that it is possible, but unlikely that region would build in such a way to trap it. That solution can't be ruled out. And of course, this is the fantasy land that we explore. But in terms of the season in general, we had, as Irma would indicate, quite an active season. So this is accumulated cyclone energy, which is a measure of the total activity or total, essentially, activity of either a single storm or the entire basin for the year or the year up to this point. So this is from Colorado State. They have the accumulated cyclone energy for each of the basins, and then in parentheses, the average for this time of year. So the amount of ACE you typically accumulate between January 1st and September 14th versus the amount of ACE on average, versus the amount of ACE that we accumulate this year. And there's a couple of things that stand out here. One is that the Atlantic is well above normal, about 2.3, 2.4 times above normal. And that's almost entirely attributable to really to Hurricane Irma. Irma generated almost 70 points of ACE. If you took away 70 from that, you'd be right around average, just below average. So really, you get a single storm can really have a major impact on ACE. In fact, Irma had the second highest accumulated cyclone energy in the satellite era, behind only Hurricane Isaac in 2004. It's about 3 points higher. If Irma had stayed east of Florida and moved into South Carolina, it would almost certainly have set the record. But regardless, it's quite high. And so, 129.2 ACE, which is what we have, of course, through now, is greater than, substantially greater than even the average Atlantic season. So we've already had an above average season in terms of ACE. In fact, I think I put my notes yesterday that if the season ended today, we would rank 21st out of 68 seasons since 1950. So that's substantially above average. For comparison, the highest ACE ever was 2005. That was 250 ACE points. The lowest ACE was 1983 with 17 points. We saw a major hurricane every landfall in the U.S. where just the total activity was very low.
Alex, do you know where 2005 was like in mid-September? I went through January.
I do know that it was. I was actually thinking about that yesterday when I was compiling this. It would have been a lot lower because you still have Wilma, you still have Rita, still had. I guess those are the two big ones after that. There were still a number of other storms, like. Yeah. So I would imagine I would fathom they were somewhere around, my guess would be around 170, 180 at that time. So higher than we are now, but we're still really, really well above that. And so if Irma had been a hurricane season itself, it would have exceeded 22 of the hurricane seasons in the Atlantic between 1950 and 2017. Which, of course, that varies with the square of the wind speed. So, in the time the storm lasts, so a 2-day-long tropical storm that has a maximum wind speed of 50 miles an hour is going to generate 100th of the ACE that Irma does. So it's basically a way to count for activity other than named storms, hurricanes, and major hurricanes. It takes the time the storm storm lasts, which is a good proxy for total activity. Another interesting thing here is, at least currently, the North Atlantic is #1. It's quite rare to have the North Atlantic beating the Western Pacific in terms of ACE. Now, if I had to guess, I don't think that survives to the end of the year, because whereas the North Atlantic tends to shut down in October and November, the West Pacific is often quite active in October and November. You often get the really big typhoons that head for the Philippines in November, even into December. So my prediction would be that the West Pacific does overtake the North Atlantic in terms of ACE this year, but the fact that it's even close is indicative of substantially above average activity in the North Atlantic, and then substantially reduced activity in the Eastern Pacific. And in terms of what to expect for the rest of the season, I really think that there's really no reason that the rest of the season won't be fairly active. This is the sea surface temperatures. And we've seen some cooling in the Atlantic mostly from the passing of Irma, honestly, in a way. But you also see, what we see is a La Nina type feature developing in the Eastern and Central Pacific. And La Nina seasons tend to be notorious for late season development, because simply the La Nina late season, the idea here is late season, most of your development's in close in the Western Caribbean. Lower water temperatures in the East Pacific reduce the wind shear over the Western Caribbean during late September, October, November. And that can mean that the shear is low enough for cyclones to form, because it's not water temperature that shuts down the season. Like, the waters in the Caribbean are warm enough for a hurricane to move from year-round. It's the wind shear that really just ramps up starting late season. And basically, in La Nina years, it tends to ramp up less. So you get more likely to get storms in the Western Caribbean into October and even November. So most La Nina years, technically, and now technically we're not in La Nina. The current conditions are neutral. I don't want to say there's a La Nina when there's not, but the sea surface temperature pattern certainly is beginning to resemble that which is consistent with a La Nina. So I think with that, and that's the general climate models from the JMA to the EC to CFS are all predicting that La Nina signature to continue and to actually become the most recent ones that climate models are predicting the La Nina to develop in the fall into the winter, which on a more personal level is relevant to my stepfamily's farm in Washington State, because that can affect the amount of rain they get in the late fall when they're trying to harvest the potatoes. So be careful, because more rain in the fall, the more likely the potatoes are going to rot and drown with harvest. So if we look at the climate forecast models, this is the CFS, but we get an indication of what, say, the pressure and shear will look like for the remaining weeks of hurricane season. I'd say, again, this has to be taken with a grain of salt, but can be used as, among other things, for guidance. So if you look at the wind shear numbers, so this is essentially the zonal wind at 200 millibars, which is a proxy for wind shear. Purple in the Atlantic is good for development, red is not so good. So you see that, at least toward the end of the season, there's a period of enhanced shear during late September, and then into October, it's really lower shear than average in the Western Caribbean. It would indicate the possibility for development. And then something similarly, the surface pressure, sea level pressure, shows low pressures in the NBR, so you might get more NBR development going out to sea, but also in the Western Caribbean period through really the late October. So I would say that obviously one cannot predict that a tropical cyclone will form a month and a half out, but based on what I'm seeing, it seems that conditions will remain relatively favorable relative to climatology for most of the rest of the season in the Atlantic. Now, of course, after mid-September, the climatology has become less favorable. Here increases, water temperature decreases, and so Yeah, I definitely would. I don't think that the recent activity in the heart of hurricane season is going to fluke. I think that it will continue in the late September and October. We could even have the next storm forming in the next couple of days as the DFS Bureau where it indicates east of the islands, and then likely tracks either north of the Caribbean or into the Caribbean Sea. So that's too early to really say anything about except that there probably will be another storm to talk about in the week. And so I think the take-home message for this in terms of our weather is great weather, great weather for this weekend, wonderful weather for the football game. It'll be mostly sunny, high around 80 this year. Very nice weather all day. Good weather into next week, pretty much similar to that upper level ridge that's building in and being fairly stubborn. Same ridge, essentially, that may cause Jose to stall out after a recurve. Jose is likely to recurve east of the U.S., although we need to keep an eye on it still because the models could be underdoing the strength of the ridge. And this is the most recent UK book that came out. So it still looks like it keeps it east of the U.S., but not far east of the U.S., but not far enough east of the U.S. for comfort. In fact, I would say not far enough for comfort at all if you live on the Outer Banks or you live in the UK. So something to keep an eye on. The 12 UK map has shifted somewhat west. So again, that's why I'm saying landfall is unlikely, but cannot be ruled out. I would certainly, I guess beach season is probably winding down in that part of the world. But certainly if I would, if I had interest in, like I think anywhere up north to North Carolina upward, I would definitely keep an eye on the storm. One potential saving grace is that the water temperatures off the mid-Atlantic and Northeast are somewhat lower than normal. And that is very different from the last couple of years where they were well above average. So I think last year, a couple of years ago, there was really 25, 26 Celsius degree water, which is really kind of the marginal temperature to sustain a hurricane. Up almost to New York Harbor, which was shocking to me. But this year they are substantially cooler in that, in that part of the world. And you can see really 2019, 22. So the storm's moving up this way, so we lose a lot of steam. Of course, if it stays westward, does what the UK does, or moves into around the Outer Banks and into the Delmarva stuff, it really probably won't lose that much strength. But yeah, that's the upside in terms of Jose. Still a potential threat to the East Coast. I think it stays east. I think there are enough of a weakness in the ridge develops that it moves out to sea. But certainly it cannot be ruled out that it either gets far enough west initially, as the UK suggested, or that enough sort of bridging builds in to send it back west to some of the 12C or 6C GDFS ensembles before that. So,
what's the chance of an ET in Jose, do you think?
The ET of Jose is fairly low because there's no trough. There's really, eventually there would be, but in the short run, not that great. It certainly will, its tropical characteristics will weaken as it moves north and north. But there's no real, there's no real forcing, there's not a whole lot of baroclinic forcing on Jose as it moves north. It's essentially just moving into a weakness in the ridge, not so much a trough itself. So there's no, just being a euro from CRC, there's no real trough coming to pick it up. Of course, there's some weak trough. It still certainly loses its tropical characteristics, but it may simply weaken more than undergo ET when it moves into the Atlantic. If it does that, which again is another thing that should protect, say, southeastern New England. If you have a trough coming, it will, one, speed the hurricane up, and two, depending on the angle you do the baroclinic interaction, you can strengthen it, basically make it weaken less rapidly, you can strengthen it. Whereas if you just have the hurricane moving into a weakness in the ridge, they'll tend to move more slowly, so longer time over the cold water before it gets to southeastern New England, and also won't have much baroclinic forcing for precipitation. Others got that as, they won't have as much shear, to make it even less rapidly. So there's always the sort of tropical exotropical interaction is always the sort of interplay between does you get air reinforcing that helps the storm, or do you get shear, another type of air reinforcing that weakens the storm, and which of those two dominate. So in this case, it doesn't look like there's going to be a whole lot of either. So it's going to be fairly slow moving, probably you can substantially over the holding water, but it's less likely to shear apart. Now that's somewhat moot if it's what the UT Med is saying, the wave part. But that's, could be a protective factor during studies.
Anyone else have any questions for Alex? All right.
Yes.
Good math presentation.
Oh, thank you. I know giving this website, I gotta give it, tropical tidbit made by Cal, is the best freaking website I've ever seen in terms of the amount of data it shows and its user friendly. So I think he has a Patreon page and you can donate to support it. He's running it all just by himself, I think. So it's certainly want to be some money to even hurricanes that are forecasted just yet, Twitter will post maps from there. It's really, really well done.
And I know we're very lucky to have Alex from Maryland, the youth advisor and the group. Thank you.
Thank you for the opportunity.